Hello guys, today we are going to discuss bridge network and we will apply mesh analysis. So for loop 1, for loop 2 and for loop 2 we can directly find a equation for loop 1. So according to mesh analysis, so I current is flowing in a loop 1, so the associated resistance 3 ohm, 4 ohm and 2 ohm. The mutual resistance among I1 and I2, which is 4 ohm, and among I1 and I3, which is 2 ohm, which is 2 ohm among I1 and I3, so which is equal to 20 volt, which is equal to 20 volt. So this is a direct equation according to mesh analysis. So from where this equation we get this equation? So if we apply Kirchhoff voltage law for loop 1, so rise in potential is E1, E fall V5 minus V1 minus V3, which is equal to 0. Now V5 minus V1 minus V3 is equal to E. Now putting the value in this equation, V5 is 3 ohm and current associated with this resistor is I1. So V1 is a mutual resistance, so for this I1 minus I2 and resistance 4 plus V3 is a mutual resistance among I1 and I3, so I1 minus I3 with a resistance 2 ohm. Now if we simplify this equation, 3I1 plus 4I1 minus 4I2 plus 2I1 minus 2I3 is equal to 0. Now I is common among these three, so 3 plus 4 plus 2, so I is common this. Now 4I2 4I3, so we found that equation which we use for loop 1 through mesh analysis. Now put that equation here. So for loop 1 we got this equation. So this is for loop loop 1. For loop 2, through mesh analysis we can easily find the equation. How can we easily find the equation? So in a loop 2, I2 current is flowing, so the resistor associated with this I2 is this, and the mutual resistance among I2 and I1, which is 4 ohm I1, and the mutual resistance among I2 and I3 minus 5 ohm is equal to 0. So if we simplify this equation, it will become like this: minus 4 I1 minus, this is equal to 11 I2 minus 5 I3 is equal to 0. So this is the final equation for loop 1. So now equation for loop 2 is equal to minus 4 I1 plus 11 I2 minus 5 I3 is equal to 0. So it is for loop 2. How can we find this equation? So we found this equation directly by mesh analysis. If we apply KVL law, Kirchhoff voltage law according to loop, loop 1, so minus V1 minus V3 minus V2 is equal to 0. So V1 is among loop 1 and loop 2. So I2 minus I1 with a resistance 4 ohm minus V3 is among loop 2 and loop 3. So I2 minus I3 with the resistance, this one, and resistance R2 and I2 is equal to 0. If we simplify this equation, if we multiply this whole equation with the minus sign, so it will become like this: I2 minus I1 with a 4 sign plus I2 minus I3 5 plus 2I2 is equal to 0. Now now 4I2 minus 4i1 plus 5i2 minus 5i3 plus 2i2. So if we simplify this equation, so here I2 is common among 4, 5, 4i1 minus 5i3. So the final equation for loop 2 is this one. So final equation for loop 2 is this one. So for loop 3 we can directly find the equation, so we know the method from where this equation comes. So the resistance associated with I3 is 2, 1 and 5, and the mutual resistance is actually 2 ohm with I1 minus 5 ohm with I2. So 8i3 minus 2i1 minus 5i2 is equal to 0. So this is the final equation for loop 3. So minus 2i1 minus 5i2 plus 8i3 is equal to 0. So this is our final equation for loop 3. So let's convert this equation to a matrices form. Now here 9 minus 4 minus 2 minus 5, 8, 11 minus 5 minus 4 minus 2, I1, I2 and I2 and I3. So this is a 3 by 3 matrix. So this is a 3 by 3 matrix. So according to a Kramer rule, when we are going to find I1, so for I1, so this is actually AX is equal to B form. Now so when we are going to find I1 current, we are going to find the determinant of this matrix and determinant of matrix where column 1 is replaced with a matrix B. If we replace column 1 with matrix B, and 8. Now so here the determinant of A matrix is actually equal to 315 and determinant of this matrix is actually equal to 1260. So I1 is found 4 ampere. So we found that we found that if we remove all this equation, we found that I1 is actually equal to 4 ampere. So for I2 we replace column 2 with a matrix B. At the end of the video I will tell you how to find the determinant of this matrix. Now we are directly putting the value here in this matrix. So this matrix, the determinant of matrix A is actually 315, and the determinant of this matrix is 840. So this is actually equal to 2.6. Now I2 is equal to 840 2.6 ampere. For I3 we replace column 3 with matrix B. Now I3 is actually equal to 315 and this is equal to 840. Now we found that I3 is actually equal to 315 840 is actually equal to 2.6 ampere. So all of the three current we have been found. Now how we are going to find the determinant of of 3 by 3 matrix. So let's put this step also added to the video. Let's add. So for example, if we got this matrix and we are going to find the determinant of this matrix, so 9, so here with a plus sign, and now here it is -4 and minus. So for this we will put minus sign, but here minus is present too, so we put plus sign. Now so for this it is minus sign and minus with plus. So -4 -2 11 and 5. 8 cross 11 cross 11. So 5 with plus sign and minus 25. Minus 4 cross 8 plus minus 5 2s are 10 minus 2 20 plus 20. Here it's 22 and minus sign with minus become plus, so plus 22. Now if we solve all these, it become equal to 315. So that's the end of the lecture, and it's a detailed lecture. We can easily apply mesh analysis going to the Kirchhoff voltage law. So but if you made a small mistake, all of your calculation become wrong. So try to start from the initial step and solve the problem. So thank you for watching.